significant figures. Objective: identify the number of significant figures in a measurement. What are the rules to determine the number of significant figures in a measurement? 1. Any digit that is not a zero is significant. 1 or more zeros between non-zero digits are significant. 1 or more zeros at the end of a decimal number are significant. All the digits in a coefficient of a number written in scientific notation are significant. Zeros are not significant if they are at the beginning of a decimal number. And zeros are not significant when they are used as placeholders in large numbers without a decimal point. These are the 6 rules to identify significant figures in a measurement. What is an alternative way to determine the number of significant figures in a measurement? The PLAR method. If a decimal point is present, then count all the digits from the first non-zero digit from the left side of the measurement. For example, 0.0035 cm. A decimal point is present, so we will count the first non-zero digit from the left. All the numbers from that digit to the right are significant. Here we have 2 significant figures. Now, if a decimal point is absent, then count all the digits from the first non-zero digit from the right side of the measurement. For example, 250 centimeters. Coming from the right, because the decimal point is absent, we have 2 and 5. Further examples are 0.00305. A decimal point is present, so we count from the left. We have 3 significant figures. Here we have 0.003050. There's a decimal point present, so we come from the left side. After the first digit, everything is significant. There are 4 significant figures. Here we have 16.35. Coming from the left side, the first non-zero digit is 1. Therefore, everything after that is significant. Another example, 10.35 cm. There's a decimal point present, so we come from the left. The first non-zero digit is 1, so everything from 1 and after is significant. 4 significant figures. Now, 20,500 cm, coming from the right, because the decimal point is absent, so AR, we're coming from the right side. 5, 0, and 2 are all significant. 2605, decimal point is absent, so we come from the right. From 5 and onwards towards the left, all the digits are significant. And finally, 265, coming from the right side, decimal point is absent, all the digits are significant. This is an alternative way to determine the number of significant figures in a measurement. Practice questions. How many significant figures are present in each of the measurements below? We'll use the PLAR method. Here we have 0.0078. A decimal point is present, so we come from the left. There are 2 significant figures. 0.00409. Decimal point is present, so we come from the left. The first non-zero is 4, so there are 3 significant figures. 0.00590, decimal point is present, so we come from the left. 3 significant figures. 2.500, decimal point is present, so we come from the left. 4 significant figures. 20.50, decimal point is present, so we come from the left. 4 significant figures. 6.00, decimal point is present, so we come from the left. 3 significant figures. 5,600, there is no decimal point. Therefore, if the decimal point is absent, we need to come from the right side. The first non-zero is 6, therefore our answer is 2 significant figures. And finally, 985. There are no significant figures, we come from the right. First non-zero digit is 5, 3 significant figures.